Have you ever looked up at the night sky and wondered what's really out there? Sure, we can see stars, planets, and galaxies, but what we see is just a tiny piece of the cosmic puzzle. The two elusive forces make up about 95% of the universe, yet we know almost nothing about them. They're invisible, mysterious, and they challenge everything we think we know about space. But don't worry, we will break it all down for you. By the end of this video, you'll understand what dark matter and dark energy are, why they're so important, and how they could be shaping everything we know, or think we know, about the universe. So grab your telescope, or just your imagination, and let's explore the hidden forces of the cosmos together. All right, let's start with something we all know: the universe. Look up at the sky at night, and you'll see stars, planets, galaxies, all the bright stuff we've been observing for centuries. This normal matter, the stuff that makes up everything from your coffee mug to entire galaxies, is called baryonic matter. It's what science has been able to study and understand for a long time. But guess what? All that stuff, the stars, planets, galaxies, only makes up about 5% of the universe. Yeah, you heard that right, 5%. Everything we see and interact with is just a tiny fraction of what's really out there. The other 95%? That's where dark matter and dark energy come in. Let's talk about dark matter first. So, what exactly is dark matter? Well, in simple terms, dark matter is a mystery. We can't see it, we can't touch it, and it doesn't emit or absorb light, so it's essentially invisible. But, and here's the crazy part, we know it's there because of its effects. Imagine you're at a party and someone invisible is walking around bumping into people, but you can't see them. You'd notice drinks being knocked over, people getting pushed. You'd know something is there, even if you couldn't see it. That's how dark matter works. Scientists figured out dark matter exists because of how galaxies behave. When they looked at galaxies, they realized they were spinning way faster than they should be based on the amount of visible matter they contained. According to our understanding of gravity, those galaxies should be tearing themselves apart, but they're not. Something is holding them together, an invisible force providing extra mass. That's dark matter, and it's not just a small contributor. Dark matter makes up roughly 27% of the universe. It's like the glue holding galaxies together, stopping them from flying apart. But what is it made of? That's the million-dollar question. Scientists think it could be composed of exotic particles like WIMPs, or weakly interacting massive particles, or axions, but so far, no one's been able to directly detect dark matter. You might be wondering, if we can't see it, how do we know it's really there? Great question. The answer lies in how dark matter interacts gravitationally with visible matter. Remember the example of galaxies spinning too fast? That's just one clue. Scientists have also found evidence of dark matter through something called gravitational lensing. Gravitational lensing is when light from distant objects, like galaxies, gets bent as it passes through regions filled with dark matter. This bending is exactly what you'd expect if there were extra, unseen, mass warping space-time. It's like looking at a distant object through a warped piece of glass. The distortion tells us there's something there, something massive, but invisible. Okay, so we've covered dark matter, which acts like the universe's glue. Now let's talk about dark energy, which is a whole other level of mystery. If dark matter holds everything together, dark energy is doing the exact opposite. It's pushing everything apart. In the 1990s, scientists made a shocking discovery. The universe isn't just expanding, it's expanding faster over time. This was unexpected. For a long time, everyone assumed gravity would eventually slow down the universe's expansion. Maybe it would even collapse back in on itself. But nope. It turns out something is causing the universe to accelerate outward, like it's being inflated by an invisible force. That force is what we call dark energy. And here's the kicker. Dark energy makes up about 68% of the universe. That's most of what's out there. But what exactly is it? We're not entirely sure. Some theories suggest it could be a property of space itself, something embedded in the very fabric of the universe. Others think it might be related to quantum fluctuations or some yet-to-be-discovered field. It's a big question mark. So now we've got these two massive forces: dark matter holding things together and dark energy driving everything apart. Together, they govern the fate of the universe. The balance between them is what determines how galaxies form, how they move, and how the universe evolves. Imagine a cosmic tug-of-war. On one side, dark matter is pulling everything inward, trying to keep things stable. On the other side, dark energy is pulling everything outward, driving the expansion of space. Right now, dark energy seems to be winning, which is why the universe is expanding faster and faster. But this cosmic struggle raises even bigger questions. What happens in the distant future? Will dark energy keep pushing everything apart until galaxies are so far away from each other that the night sky becomes completely dark? Some theories even predict a big rip, where dark energy becomes so dominant that it tears apart galaxies, stars, and eventually even atoms. On the flip side, if dark energy weakens, dark matter could take over, leading to a big crunch where everything collapses back in on itself. As mysterious as dark matter and dark energy are, they're also incredibly exciting. They remind us that we're still just scratching the surface of what's out there. Every discovery brings us closer to understanding the hidden architecture of the universe. But there's so much we still don't know. New experiments and observations are happening all the time. Projects like the Large Hadron Collider and upcoming space telescopes aim to shed more light on these dark mysteries. Maybe one day we'll find the elusive particles that make up dark matter. Or maybe we'll develop a new theory that explains dark energy. Who knows? The possibilities are as vast as the universe itself. So there you have it. Dark matter and dark energy, the invisible forces shaping our universe. They're mysterious, elusive, and they challenge everything we think we know about reality. But that's what makes them so fascinating. They remind us that even with all our technology and knowledge, the universe still holds secrets beyond our wildest imagination. If today's talk left you with more questions than answers, that's a good thing. Curiosity is what drives science forward. Who knows? Maybe the next big breakthrough in understanding dark matter or dark energy will come from someone just like you, asking the right questions and refusing to accept that the universe is too mysterious to understand. Thanks for sticking around until the end. If you enjoyed this video, be sure to like, subscribe, and let us know your thoughts in the comments. What do you think dark matter and dark energy are? We would love to hear your theories. Until next time, keep questioning, keep exploring, and keep looking up at the stars. There's a whole universe out there waiting to be understood.